Okay, so clues to help me with this question are the fact that we're modeling the boat as a particle, but the key thing is here it's traveling in a straight line and at a constant speed. Here I've got my position vectors for the boat at two different times. So I'm just going to put them onto a diagram here. I always find it helpful just to start a frame of reference vector questions. And I can see that B1 represents the position at 10 o'clock, B2 is the position at 12:45. So therefore, because it's traveling in a straight line, then it must have traveled that line there. So I can think of that as a vector in its own right. So the vector B1 to B2. Once I know that vector there, then I can start using that to find the bearing. So let's find the vector B1, B2. So as ever, I'm going to write down what I'm trying to do. I'm going to go to B1 to 0 plus 0 to B2, which I then rearrange like so, using column vectors. So O to B2, which is this one here, -3, -5, subtract 4, -2. So 4, -3 minus 4 is -7, and -7 minus -2 is -3. So that's my vector in the line of direction of the boat. Let me just write that as I and J notation, like so. And that's going to help me to try and find the bearing, because ultimately this vector is from a given point here, let's call that the B1 point. I'm going -7 to my left and -3 down. So that's a representation of the vector that we just established. Now I'm going to put in north because I want to try and find the bearing. So the bearing that works clockwise. Okay, so I'm looking to try and find that angle. So 7 across there, 3 across there. So if I can find this angle here, I know that that's a right angle, and then I can just subtract that from 360. So let's find that angle x there. So it's tan of the angle. So tan x is opposite over adjacent, so 3 over 7. So x is tan to the -1, 3 over 7, and that comes to 23.198. And then I'm going to subtract that and 90 degrees from 360. So 360, take away 90, take away 23.198 will give me the bearing of the ship's travel, or the boat's travel. So that's 246.8 degrees. So you say to give the answer to one decimal place. So what's done? Let me collect those together, group them up, and then put them to one side for a moment. Let's put them down there. And let's focus on the next. It says calculate the speed of the boat, giving your answer in kilometers per hour. So the question has the positions vectors in kilometers. I've been given a difference in time. So what's that? 2 hours, 2.75 hours. So time is 2.75 hours. And I can use, because I'm trying to find out the speed, I can use the formula speed distance time. Speed distance time, where speed is distance divided by time. Now to establish my distance, the distance that the boat has actually travelled is equivalent to the vector magnitude that I've actually just discovered, B1 and B2 vector. So that's 7 squared plus 3 squared. So 49 plus 9 gives me 58, so root 58. So that's the distance, and because it's in kilometers, that's the distance in kilometers there. So the speed is the distance divided by the time, and that's going to give me 2.77 kilometers per hour. And that's going to give to 3 significant figures.